Hello and welcome back to Unicast Administrators. Today we are going to have a look at containerization inside Linux, and specifically we are going to look at Podman and how we can create our first container, how we can look inside the logs, how we can inspect an image, pull an image, and of course also how we can remove them if we want to clean up our container environment. So thank you for joining. I hope you like this. Enjoy it and let me know what you think. For today, I have decided to go with Podman, which is an open source container solution that was first built and developed by the Red Hat engineers. And the main idea behind that is that Red Hat wanted to provide an alternative to the container solutions that were already in place, and mainly they want to provide an alternative to Docker. Well, Podman it's very similar to Docker. As a matter of fact, I even think that it's a replica of Docker. And if, for example, you want to run a container inside Podman, you do that with the command podman run, whilst on Docker you would run them with docker run. So the Podman syntax is similar to the way Docker runs. I believe, as far as I know, or as far as I have encountered this, the only difference is that when you want to clean up your containers metadata and cache, Docker has the prune, whilst Podman has a different solution that I cannot remember now. But that's the only difference that I have been able to find myself. And for example, Podman can be installed on different operating systems like macOS, Windows, and of course different distributions for Linux like Arch Linux, Manjaro, CentOS, Alpine, Ubuntu, Fedora, and so on. I will install Podman on two different servers. One is an RHEL 9 from Red Hat, and one is a Rocky Linux 9. But if you want to install it on a different operating system, you can do so using this particular procedure from podman.io/docs/installations, for which I will also provide the URL link in the description of the video. But as soon as you finish with the installation, everything else that will be on the video, you can apply the exact same commands as they are one and the same. The only thing is that the installation differs based on the operating system where you want to install it. And if you want to read the official documentation from Podman, you can do so. They have a very good written documentation where you can start from the page getting started, and you can go, as soon as you finish with the installation, you can go and test different commands, and you can follow their guide like searching, pulling, and listing images, which we will do in our video as well, running containers and so more. So if you want to go even more in depth with Podman, you can do so using this particular documentation, which is their official documentation. And if you want to read even more about Podman, you can even have a look at this community letter from Red Hat, where they talk about what Podman is, what are the pods, and so on. So as of now, Podman it's an open source tool. Even though it was developed by the Red Hat engineers, it has been provided to Fedora as an upstream, and you can also install it on your different distributions or different operating systems as well. But before we proceed with the installation, I would actually like to describe a bit what the containers are. What is the containerization solution for the people that maybe have not yet worked with containers, either Docker or Podman, So before we start with the actual installation of Podman, I think it's vital to discuss a bit about what containers are, and based on the official definition of what a container is, a container, it's a standard unit of software that packages up code and all of its dependencies in such a way that the applications can run quickly and reliably on your servers or clusters of servers, having the least footprint. So that basically means that containers are just a block of code for different applications or softwares and applications by themselves, but the advantage here is that it takes less resources, it uses less resources from your servers. And here I brought a graph that shows how applications used to run in the past on virtual machines or servers on basically using the old method. So you had the server, which basically it's one particular server in a rack where you have the hardware part, on top of which you put the operating system, and that it's then brought up through a hypervisor and made of virtual machines that can be used by the end users. On top of which, aside from of course the guest operating system, you have your binaries and libraries, which basically mean that there are dependencies required by the operating systems and applications themselves, and on top of that you would run your applications like MySQL or an IIS website or an HTTPD website or any other application that you would want. So this is the old method. The new method that has been used during the last couple of years is to run your applications inside the containers. So that means that you still have the old let's call it the old topology that you had on the server, the hardware part where you put your operating system on top. But aside from that, from your operating system you install your container engine, which can be Docker or Podman, and on top of that, inside the Docker or Podman engine, you run your binaries and libraries, and you have your applications like MySQL or web servers or any other applications that you have. So basically this means that your resources from your operating system, from your server, will have more free resources that can be used in a different area. Running applications inside containers running application inside containers puts less stress on your resources. That means that it will utilize less CPU, less RAM, and less space. Of course, that depends on the applications that you run inside the containers. For databases, there will always be the storage issue. It's not so high as the old method of running databases directly on the servers, but still running a database inside the container still uses a lot of space. Not that much, but still a bit. But I think I thought about a different explanation to make containers easier to understand, or at least this method was easier for me to understand. So here we have a graph of an apartment with different rooms, kitchens, bathrooms, and so on. Let's think of your server, either if it's a physical server or if it's a virtual server inside the hypervisor like Hyper-V. Think of your server like your house or the building that has multiple apartments. Well, a container, it's an apartment inside a building, and inside that apartment, which you can think of it as the container, you have your rooms, or you have your kitchen, your bathroom, your balcony, and so on. Basically, those are the applications. So you have the container engine, which is Docker, or Podman, which is your building or your house, and you have inside your container your apartment that stores different applications, which in our case can be a kitchen, multiple bathrooms, a bigger balcony, or multiple rooms. This is the way that was easier for me to help me to understand exactly what containers are. So I hope this helps. If not, you can always revert back to what Podman offers on their official website, where you have all the documentation, and they go in depth of explaining each and every single step and exactly what Podman is and how containers run. But I think this gets the point explained. If not, let me know and I'll make another video on how to explain this even more. Alright, so let's get to work. I have two servers. I'm currently using VMware Workstation Pro 17. Of course, I don't use it for production. I only use it for personal use to test my different things. And currently I have two servers installed. Actually I have more servers, but the ones that we are going to focus on today are RHEL 9, an RHEL 9 from Redhat, and one it's from Rocky 9.4. The reason why I chose to show the installation on both of them is that, first of all, RHEL comes with a paid subscription. You have an option to obtain a subscription which is free, and you get that with a Red Hat developer account that you can use only for your personal use and for your testings, like I do on my home lab environment. And the other option, it's free. So Rocky 9.4, as I said in my previous videos, CentOS, Fedora, and Rocky and RHEL are all one and the same. The only difference is that Fedora is the upstream where everything is tested, built, and shared separately, then to Rocky, CentOS, and then RHEL. And whilst CentOS Stream, Rocky, and Fedora are free, RHEL it's not. RHEL comes with a corporate paid subscription and comes with corporate support, of course. So if you don't want to go through the hassle of making your Red Hat developer account and you can obtain through that subscription, then you still have the option to go with Rocky or CentOS or Fedora. And this is the reason why I chose to have Podman installed on two different servers. So for example, in my RHEL 9 server, I already have Podman installed, and I can query for that using Podman, which, as you can see here, I have multiple packages installed. So I already did that here, but I'm gonna show the installation on Rocky 9.4, and it's one and the same. If you want to install CentOS on, if you want to install Podman on CentOS, Fedora, or Rocky, or RHEL, the installation is one and the same. And of course you can have a look on the installation page, but I like to show it like this. So first of all, when I do not know something, I look it up with the dnf provides command with an asterisk and /, and I search for words. So for example, if I search for container, dnf provides will do a query and it will show me which packages provide containers. And here we can see that we do have some small packages that come with the name container, and they come pre-installed from higher packages, which are Ansible Core, Boost, and so on. But none of these packages actually offer me container or Podman. So in order to install Podman, you run the command dnf install and the word dnf-tools. Sorry, I meant to say dnf container tools. So the way to install is dnf install container-tools. And as soon as I hit enter, it will go through a small search, and as soon as that is done, it will prompt me with the findings, and it will prompt us, and it will ask us if we really want to install container tools or not, and then we are going to press yes. And I did that without giving it the -y input to install it directly, so that I can also illustrate this step. So I'm going to pause here and come back as soon as this is found. Alright, so our DNF search has finished. It took a bit longer because this is actually the first time when I'm using DNF on this particular server. So we search for container tools, and we can see that this not only installs Podman on this line, but it also installs Podman Docker, Podman Remote, and a lot of dependencies and you can call them sub applications that are used by container tools. So I am going to hit yes here. I'm going to press enter, and as soon as the installation will finish, I'll be back and I'll show you exactly how you can run your first container. Alright, so our container file, the entire Podman and all of its dependencies has finished installing. This is completed, so now we can start to play with Podman and to build our first container. Now, as soon as the installation is finished, let's also search for Podman with rpm-qa, and let's put a pipe there and search for the word Podman. And as you can see here, we already have it installed. Now I'm going to copy this command. I'm going to run it on my server 2, which is our RHEL server, and we can see that we have it installed here as well. So the installation, it's the same. The Podman commands are the same. I did the installation on a Rocky 9.4 server, but you can apply the same steps for CentOS, Fedora, and RHEL as well. So let's start with our first command, and you can run podman --help, and as soon as you do that, by default you are prompted with the most utilized commands, and you have here your usage, which is podman, option, and command. Or you can just go manual pages with podman, so man and the word podman. Let me clear my screen, and we go here, and here we have a bit more information, and I can even search for examples, or I don't think we have examples on this page. I think we we actually have to search for different manual pages. But let's cut to the chase. So the Podman, it represents the container daemon. So basically this is how you can control your containers or your images that you are going to install on your Podman. And if you do not know what's the service that controls containers, or in our case Podman, you can simply search for it with the command systemctl list -units. Let me put here a space, -- type equals service, and here you have the list of all of your services. And somewhere here, there we go, we have our containerd service. If this service, containerd service, it's not started or not enabled and running, you can ignore the messages that you'll have here. You may not use your podman command, and that's one. So how do we use Podman? Well, in order to create our first container, we first need to search for an image, and you can do that through the web. Copy the URL link, manually pull the image here, but we are going to do it from the CLI, from the command line. So let's say that we want to search for an Nginx container image. So let's do just that. So as I said, Podman, it's the daemon tool. You are using it to control your containers, and with that you can search for images as well. And I'm gonna run podman search nginx, and this will run a few seconds, and as you can see here, all of these are images that you can pull directly into your server from the web through Podman. These are container images, and we have a few, actually a lot of them. We have them directly from Redhat, from the Redhat repositories, which are starting with registry.access.redhat.com. We also have other ones that start with registry.redhat.io, and we also have, guess what, we have the Docker containers as well. So if you don't want to use any image that you have here from Red Hat, you can use an image from Docker. And as a matter of fact, this is exactly what I am going to do. I'm going to use this image here from this line directly from Docker. So if you want to search this particular container image, you run podman search and you give it the entire link or just the name, or you can, as I did here, I restricted my search to show me only the Docker containers. And there are a few best practices, because containers, due to their C name and their C groups, they also represent a vulnerability, and at the same time you don't know who the creator of that image is. And the best practice is that you should never run an image directly. You should first inspect it. And for example, if I would like to inspect this particular nginx image from docker.io, first I need to pull it, which means basically to take it out, to download it locally, which I'm going to do right now with the Docker, with the podman command and the argument pull, and then I give it exactly the location from where to take it. If you use column at the end, you can specify a specific version. Let's say that I want 17.0, or if you don't know what is the latest image, it will automatically take that particular image that has the latest version. Or you can even type in colon and then the word latest. As soon as I do that, it will try first to connect to docker.io, which it did, and now it's copying from the blob. Blob, it's basically a location inside this URL from where it's taking up that particular image. And we can see that the manifest image has finished. Basically that just confirms us that Podman has finished pulling or downloading that image. And you can now run the command podman images to see which images we have on our system. And as soon as I do that, we will be prompted with our image that we just pulled it from here. And we can see that it has the tag latest. This has an image ID which is generated automatically on our system, and it shows us a few details. For example, it shows us that it was created or last modified 13 days ago, and that it has a size of 192 megabytes. So we said that the best practice is to always inspect an image before you run it, and we are going to do just that with the command podman, which is the daemon for our container solution, with the word inspect. Actually, this is an argument, not a word, my bad. So podman inspect, and you give it the repository. In our case, since we have it already pulled locally, I can just hit enter. And here we are going to be prompted with a lot of information. So basically these are just instructions or variables or declarations, or it's simple to say them that these are instructions on how this particular image should build your container. And we can see here, for example, it shows the path, it shows the repository from where this particular image needs to be taken. We can see that it's also encrypted with an SHA-256 cipher. We have a few configurations here. So for example, it will expose our TCP port 80 for unsecure HTTP, HTTPS being 443. We have a few informations here about architecture, OS, size, and so on. So these are a few informations, but if you don't know, or if you know exactly what you need to look for and you don't want to read through this entire thing, you can run again your command docker inspect with the name of your Docker image or just the URL itself. Then you put a pipe grep -i and search for the word cmd, which stands for command. Basically, this shows us exactly what will run, what will be executed inside our container, inside our server when we run Podman. And as we can see here, this is what will run. This is the CMD that it will run. So we can see it runs a bin shell -c, and it's going to start the Nginx with the daemon off. So this is safe. This is a safe image. We know that for a fact. We looked at what it does, and of course these are also validated by Docker before they are published, and so we also know that these are safe. But it's not a bad idea for you to double check that, to verify that. So let's run our first container, and in order to run our first container, let's run again Podman, and let's run again the argument images, because we have already pulled an image. And again, you can create your containers directly without pulling them, but as a best practice and for you to be safe, you should first inspect an image before you run it. Alright, so we have our Nginx image here. Let's create a container inside it. Now, if you run the command podman ps, it will show you the current running containers, and as you can see here, we have none. But the only difference between this and podman ps -a, it's that if, for example, I will create a container that will fail to start, it will not show under the command podman ps, because podman ps shows only the running containers. If you run podman ps -a, you can see even the containers that are not running. So let's run our container, and we can do that using the podman daemon or podman command with the argument run, and we add a -d for detached. Basically that means that the podman will be created, the container, the Nginx container will be created inside podman, and it will run automatically without our intervention as soon as we finish running this command. So we are gonna run podman with the argument -d, and then let's type in here --name, and let's give it a name, and let's say that we want it to be named my -web. Then we are going to give it the path, and in our case it's docker.io library.nginx, and I would also like it to set up the local storage, persistent local storage, basically an area inside our server where podman should run. So you can do that with the -v argument, and you give it the location. So in our case, I would like it to run inside var, and then I have to put a colon symbol here, and then I type in the location inside the container, basically where the information, the data should be stored inside the container as well. And let's say that I want it inside var/lib. Then you have to type in again the colon symbol, and you also have to specify the capital Z. If you don't specify capital Z, you will have to manually set up SE Linux. And SE Linux, it's a bit of a more advanced topic, but basically it's an extra security feature that works with labels inside Linux. And if you don't specify capital Z, you will have to either disable your SE Linux, which is not a bad thing, but it's also not indicated as well. It's not a best practice. Or you have to manually allow or create a particular label inside SE Linux that will allow your container to run. So we don't want to go through that hassle. Therefore, you make sure that you specify at the end column capital Z, and that will allow your container to use the persistent storage. Then we also want to specify the port where this particular container should run, and in our case it should run on port local port 80, and the container port inside the container should be 8080. You can leave it 80, you can leave it let's say 81. Let's leave it at that. And as soon as I run podman run like this will install my container. Let me make this a bit bigger so you can see that exactly. Let's hit enter, and as we can see, this has already installed. It was that fast. Why? Because we already had the image saved locally when we downloaded it with podman pull. So let's run podman ps, and as you can see here, the container, it's not running. So we know for a fact that we run this command, but it does not show up, it does not run. So let's see why. In our case, we can run podman ps-a, and this will show us that the container has been created indeed with the name myweb. Oh, and by the way, if we did not give it a name, it will automatically give it a random name. So back to our topic. Podman ps-a shows us all the containers even if they are not running, and we can see here that our container was created around 36 seconds ago, and it exited with a particular code 127. But we would like to find out why this did not work. So let's do that. We can run podman logs, and you can specify either the name of the container, which in our case is myweb, or the container ID. You can take this with copy paste. If I run podman logs and the container ID from here, from our container that I just created, and I hit enter, we can see that docker endpoint entry points .sh something something failed to exec -v, and it's telling us that it did not that it's not found. And I think it's actually referring to this particular part where I wanted it to manually force it to use local storage. So basically this means that I think it's already created inside the manifest file for this container. Therefore I might not be able to run this command manually. So that's fine, but this is perfect because I wanted to have this issue pop up so that we can also illustrate how we can look for the logs inside a container that is not running, and at the same time to show the difference live, how podman ps and podman ps-a has its output and how a faulty container runs. And I have two options now. I can even delete this container that does not work, which I do with podman remove and the name of the container, myweb, or the ID, but I am not going to remove it, not now. I'm actually going to rerun my command that I did earlier. I'm actually going to rerun my command, but this time I'm going to create another container with a different name. So let's call it website 1, why not? And we are going to remove the part with the local storage and with the port as well. Why? Well, when we looked earlier, we noticed that it was running it was opening and exposing port 80. So we don't have to manually declare the port. We can do that, and we will do that later on for a different container, but it's safe to remove that for this particular container. And we are also going to remove that particular storage as well. So we can run our container with podman run -d -- name. We give it the name of website 1 and we give it the location, and this will run immediately because the image is downloaded locally. So let's hit enter, and we can see that a new ID has been generated for our podman container. So let's run again podman ps, and would you look at that, our website 1 is running. So again, let's do a podman ps -a, and we can see that our first attempt to create the website failed. Our second attempt to create the container for our new website called website 1 worked perfectly. So why the first time it did not work and the second time it worked? Well, let's get back and let's inspect again the image. So podman inspect, if only I can learn to type. And let's run our image, and if we go, we can see here that it runs some commands. So let's go on top and top. Let's see, it was, there we go. So it runs on port 80 directly, and we should have a bit below, there we go, up there. So we don't have to specify the directory, we don't have to specify the port either, because it created automatically. Now, normally and generally speaking, there is no issue if this is already declared and you specify it as well. But for whatever reason, this somehow failed. And I knew that because I was testing this before I decided to record, because I just wanted to make sure that nothing else changed and that the behavior was the same as the first time when I learned Podman. And it didn't, it's exactly the same, but I just wanted to make sure. So this is the reason why we went through the entire hassle, because I wanted to illustrate how an issue can appear even by running simple commands. So our container would have ran from our first attempt if we would have not manually specified the location and the port. So our container is running, we can test that. You can go inside your browser and test the connection, but let's show how we can remove a container. So we want to remove our first container that failed, which in our case it's called my web, and I'm gonna do that by running the command podman rm for remove and the word of the container, or if you don't want to use the word, you can use the container ID. And there we go. As soon as I do podman ps -a, you will see that we don't have it here. Now this only deleted or removed the container but not the image. Sorry, podman images. If we run again podman images, you'll see that we still have here the podman image command, the podman image file that has 192 megabytes. Now we removed the container but not the podman images themselves. So we still have this image. If, for example, we would want to remove that image as well, as of now we cannot, because it's used by this running container. So the only way for you to remove that would be to first of all run podman stop. Let me run the command correctly. So it's podman stop and the name of the website. Now it stopped, so we can see that with podman ps -a. And if we go with podman images and check again the images, we can see that we still have it here. So let's say that we want to remove that. And so that I won't forget before I remove this, let me show you exactly where Podman and the containers save the stores the images by themselves. So that's happening in containers. So Podman saves images inside var lib containers and then inside storage. So let's also show the storage. Now this will appear under different names. If we look inside overlay images, we will see that this will have this particular output. So you can manually remove them from here. It's not really the best practices. So Podman images will show us the image, and let's remove it with the command Podman RMI, which stands for remove images, and let's just remove our image. And it's telling us that image is still in use by a container. So let's see what container still uses this, our website. And until we remove the container, we cannot remove the image. So it's not enough only to stop the container, we also have to remove it. Therefore, let's do that with Podman RM website 1. If we list again with Podman ps-a, now we can see that we don't have it. So this time we can safely remove the image using Podman RMI for remove image, the path, and there we go. This has been untagged and has been deleted. If we run Podman images again, now we can see that we don't have it anymore. This is clear. So all the actions that we took so far, we took them on server 3, which it's on Rocky 9.4. I completely wiped out my entire container, so I don't have anything. Let's run the same steps, but let's create a database container, but this time let's do it inside the RHEL server, so that I can illustrate that this runs with the exact same commands. So let's see if I would like to run, let's think of it, which database. Let's run MariaDB. I think MariaDB would be a great example. Let's search for it. So let's run Podman search MariaDB. Let's see if we can find it. So there we go. We have a lot of repositories from where we can take this. Since we are running on Rocky, let's install them from since we are running this on Redhat, let's use the Redhat repositories as well. But we will see here that we have different MariaDBs for RHEL 7, here we have for RHEL 8. I want one for RHEL 9 because this is currently on the one that I'm connected. So let's have a look again. Let's restrict the search, Podman search. Let's run this and it will show us only this particular finding. Let's run Podman inspect and let's see if we can run it directly on this, and it's telling us that it does not have this particular object. So we have to run Podman pull and it will tell us that we don't have a registered account on RHEL. Well, we can simply get around that after we log in. And in order to log in, we have to log in on both registry.access.redhat.com and registry.redhat.io. So let's do that. Let me copy this and I will simply run. Let me clear my screen so we can see this better. So let's run Podman login. Let's give it the website, in our case registry.access.redhat.com. Let me enter my credentials. and the password. Alright, so successfully logged on this one. And now let's log in on the other one, which was registry.redhat.io, if I remember it correctly. So let me log back in on this one. Now, of course, you have to have your developer account enabled. You can do that as soon as you make your Red Hat developer account. You can get to have access to Red Hat and to the products that come with the subscriptions from Red Hat. If you would like to make me a video about how to set up your Red Hat developer account, let me know and I'll do that. But moving forward, we have successfully signed on. So let's check our history. What was the last step that we tried? We tried to pull a different image from Red Hat for MariaDB, and it failed because I was not logged on in their registries. And now that I did log on, now I can pull that registry. Now I can pull that image from the RHEL registry. So I'm gonna illustrate exactly how we can also install a Podman database, a Podman container running a database. Now I'm just pulling the information, and I'm gonna pause here as soon as that image is finished pulling. Alright, so the image has finished downloading, so let's check it out. Podman images, and here we have it. So now that we have our image for MariaDB, now we can run our container using the MariaDB image. So in order to do that, we run again podman run -d. Let's give it a name. Let's give mine my database. I think that name will work. Let me, first of all, I forgot about that. First of all, we need to create a directory where we want that particular database to save the files. Now I have already created that, but I almost forgot to mention it. So we will need to create a directory where we want that particular database to run, and we have it here. And I also created another one, so you can have as many directories as you want for different databases, but let's use my database. So let's go again and run podman. So podman run -d -name. Let's give it a name, my dbase. I think that name will work just fine. Let's set up the local storage with argument -v. So my database, which is the directory that we just created earlier. Then let's put colon, which basically states that we are now going to determine inside the path inside the directory where the files for the container should be stored. And don't forget about colon capital Z for SE Linux, otherwise we have to run different things in order to allow the container to run. And now one thing that is different from the earlier Podman executions for the new containers, it's that for databases we have to specify an environment variable, and we do that with the -e for environment variable argument. And we need to create a MySQL user, and let's say that I'm going to name mine Bernard. Why not? -e again, because we also have to set up the MySQL password. I almost forgot how to type in there. So let's type in a password. Let's say ABC 2024. That's a good password because this is just a test. Now, aside from that, we also want to create a database for our MariaDB, so we have to use another environment variable, and we are going to type in mysql underscore database, where you can give it whatever name you want, database, whatever name you want. So I'm just going to name my database 1. And now we can specify the location of our image, and in our case, because we already pulled it, it was registry.redhat.io, and as soon as you press tab, it will auto-complete. Now you can leave column latest. I'm just gonna remove it just to illustrate that it will actually install our image that we pulled it earlier. Hit enter, and there we go. The container has been created, and if we do podman ps, now you will see that it is up and running. If I do podman ps -a, you will see that I have another container that I took from Docker that I played a bit around with it, which is for semaphore, but I stopped it, so that's fine. But we can see that our database it's running. So let's do just podman ps. Let's look only at my database. If I would like to see the logs inside it, I just do podman logs and the name of our database. Now there is one thing that I have not discussed yet, and that is how you can connect to the container. So now earlier we did podman ps, podman logs and the name of the container, so we saw the logs that have last written inside our container, and these are the logs. What if we want to connect to the container, or what if we want to run specific commands inside the container? What if I want to run let's say a command like bin bash? So in order to connect to an existing container and to run commands, you run the daemon podman, type in the word exec for execute, and then you type in IT for interactive, and you have to give it the name, in our case my dbase, and let's say that I want bin bash. What this does, it opens like an, think of it like an SSH connection from your server to your container. It's not an SSH connection, you are just connecting to it, you are just attaching yourself to the container. And now I am inside the container. If I type in the command uptime, it will tell me the uptime from inside the container, not the operating system. Let me make this a bit bigger. What if I type in the command hostname? I'm curious if that would work, and it does work, and it gives us the name of our container. And have a look at this. So we ran podman ps from our server, and we noticed that our container with this image has been created, it's up and running, it gave it the name my database, but that's the name inside our server. The actual name inside the container of the container itself, it's the container ID. So pay attention here. As soon as I typed in hostname, from inside the container I get the same return, which is container ID. And of course I can type in any Linux commands as long as they are available. For example, I typed in pwd and I can see that I'm inside opt app root src. What happens if I type in cd to go one step earlier? And there we go, we can see what's inside here. Let's see, what do we have here? So we are inside opt. We see, do we have, yes we do. So inside the container we are inside root. I could have simply typed in cd root, but I just wanted to see if anything else was inside that. So everything that we have here, it's from inside the container itself. So let's go in var, let's see what we have here. And I'm curious if we have, there we go, we have var log. So let's see the on log, and let's see what we have inside var log from inside the container itself. And we have a few logs here. For example, we have one for Maria DB. Oh, actually, my bad, this is a directory. Let's go inside it, and apparently we don't have anything inside this one. Right, so it's just a directory that was created by the container itself. What if we try to cat Hawkeye? Yeah, we have some logs here. So anyway, I am now inside the container itself. I am not on my server anymore. I am attached to the container itself, and I wanted to connect to the container itself to show you how you can detach yourself from the container without shutting down or without stopping the container. And in order to do that, you have to press the control button and P and then control Q, and that should disconnect me from the running container. And as you can see here, it already disconnected me from that container. And if I do Podman PS, I can see that the container is still up and running for 5 minutes. So in order to detach yourself from a running container, you run control.p plus control.q, and this is the sequence. You have to run them in sequence. So if I want to stop an existing container and an existing running container, I can type in simply the command podman stop, give it the name, my database. Now podman ps-a, I can see that my database is stopped, and I'm also going to remove my database container because I don't want it anymore. This was just an illustration. So again, I have removed my Podman container for my database, but if I run Podman images, and as a matter of fact, let me also clear my screen, we can see that if we run Podman images, that image, which has a size of 470 megabytes, it's still present. So Podman RMI, give it the path or the name of the repository, and there we go, it has been removed. So if I run Podman images once more, it will show me that this is not present anymore. So this was it. This is how you can install and run your first containers. But of course, this was just an easy setup to get you started with Podman. But Podman and Docker and containers in general they have some higher topics that you can go into, and we can even talk about Podman rootless containers, which basically mean that normally users can create containers inside Podman, and if root allows them through the command loginctl enable linger, you will be able to allow end users to create containers, and those containers will run automatically even if that user is not logged on upon reboot. So Podman has some higher and more advanced topics which we can discuss in another video, but for now I think that's more than enough, and I hope you enjoyed it. Let me know if this was something that you're looking for. Let me know down in the comments section down below what you would like to see next, and if you want to go more in depth with Docker, let me know, or with Podman, and I will make another video about it. So thank you very much for taking the time to watch this. I hope you enjoyed it. Have a good day and all the best, and see you next time. Cheers.